On this video, I just wanted to recap some examples of concepts we've already covered. The limit as x goes to positive infinity of x cubed minus x squared. That's the limit x goes to positive infinity of entity. We factor out x squared and we get x squared times x minus 1. And then by the infinity rules, we can break this apart like this. Both of these limits go to infinity. The only danger is we would never want infinity times 0, but that doesn't occur. So we're good to go. So the limit x goes to infinity of x squared, positive infinity at that, times the limit x goes to positive infinity of x minus 1. Well, both of these limits you can tell are positive infinity, but for completion, I break this limit up as limit x goes to infinity of x minus limit x goes to infinity of 1. But that's just, this limit is positive infinity, and this limit here is positive infinity as well, because positive infinity minus 1 is just, again, positive infinity. So we get that right there, and then in positive infinity times positive infinity is positive infinity, and we're done. And notice this would not constitute it would constitute neither a horizontal nor a vertical asymptote, because it's not a horizontal asymptote because our final answer was infinity and not a finite number. It's not a vertical asymptote because we had to take x to infinity in order to get infinity. So, limits where x and y both go to infinity they're disinteresting as far as asymptotes go because they're not going to give you one. If the y coordinate goes to infinity as x goes to infinity of either kind, if y goes to infinity of either type as x goes to infinity, if y goes to infinity of one particular type as x goes to infinity of some particular type, you're not going to get an asymptote. And likewise here, I use negative infinity. I do the same stuff. Now, negative infinity squared is going to be positive infinity. Now, but now in here, we're going to get negative infinity because, we're just taking this is x and not x squared now. So we get positive infinity, and now negative infinity minus 1 is negative infinity. So positive infinity times negative infinity is negative infinity. So this time the limit's negative infinity because as x goes to negative infinity this time. And I'll leave it for you to do this guy right here. You'll factor out x to the 7th, and you'll get x to the 7 here, and you'll get x cubed minus 1 here, and then you can just break it up like this. You don't need to do a difference of cubes unless you just want to. If I were you, I'd just follow what I did here and here. Okay. Or either here. Well, actually, yeah, just follow what I did up here. You're good. Now, going down here, I take the limit as x goes to positive infinity of this guy. The trick is to remember cube root is x to the 1/3 power. The square root's x to the 1/2 power. So we get this. Then you factor out the smaller guy, x to the 1/3 power. Times, you remember, you factor out x to the 1/3 power, you subtract 1/3 off this, which just gives you x to the 0, which is 1. You subtract 1/3 off a half minus a third is a positive 1/6. Remember, do your fraction arithmetic there. So that's 1/6 in the exponent. Okay, then break this apart, and then and it's sort of like we did that other one. And then you just limit x goes to infinity of x to the 3rd power. Well, as x goes to infinity, the cube root of x is going to go to infinity a little slower, but it'll go toward infinity. And then, now be careful here, you get 1 minus infinity, which is negative infinity. So infinity times negative infinity is negative infinity. And it ought to be that, it seems like it ought to be that way because x to the half is the bigger guy, if you're going toward positive infinity. It's going to outmuscle x to the 1/3. But anyway, so I'll leave it you to do this one and this one. Now, guys, on this one, you want to treat x as x to the 1 power, and of course the square root of x is x to the 1/2 power, and you'll factor out an x to the 1/2 power here, and that'll leave an x to the 1/2 here minus a 1 here. But anyway, just go to town with it, and you'll be fine. You do it like we did these others I just went over. And again, these are worthless as asymptotes because they're not asymptotes. But now we'll talk a little bit about vertical asymptotes and horizontal asymptotes. Out of laziness, I let VA stand for vertical asymptote, and I let HA stand for horizontal asymptote. So just be mindful. the limit as x goes to 0 minus of 1 over x is negative infinity, and really you could stop there. We just need one of these. Either one is fine. X equals 0, the vertical line, x equals 0, which is the y-axis, is a vertical asymptote of the graph of y equals 1 over x, for the reason listed directly above. Right? Either one of these. We don't really need both. We just need one of them. Either one of them. Okay, the limit as x goes to 0. Now this is 1. We didn't get infinity, we got 1, so it's not a vertical asymptote. It's an empty hole or a removable singularity. And I'll type that here just to be complete about it. Give me a sec, sorry about that. So there's that, and I can't spell it, it corrected it for me. There it is. Actually, I can spell okay. I can spell reasonably well, but anyway, I didn't do it this time. So removable singularity. Moving on. Limit x goes to 0 plus of this guy right here. Now that's more interesting. The trick is to break it up, and I don't know what I was doing, putting a plus sign there when a times sign belongs there. Sorry, guys. Clumsy it is. So that needs to be a times sign. So remember, the product of the limit is the limit of the products. 1 over x times sine x over x is sine x over x squared, but I want it broken up like that. And that's okay. It's okay to have one of them be infinity as long as the other is not 0. And neither one will be 0. So this is positive infinity. This is positive 1. And that's a times sign. I did it again. Sorry. So it's infinity times 1, and that's positive infinity. And so x equals 0, yes, it's a vertical asymptote of the graph of y equals sine x over x squared. But notice that was less obvious. We actually had to go in and get our hands a little bit dirty to see that, but it was true. Now, the cosine, you don't need to go, like sine, we went to x squared. You know, x wasn't good enough. Now for cosine, x is good enough, because cosine doesn't vanish at 0. So, in fact, you can break this up. You know, cosine times 1 over x is cosine x over x. And, but now the limit as x goes to 0 minus the cosine. Cosine is just totally continuous. You know, x could go to 0 itself as far as the cosine cares. You just get cosine 0. And so we get cosine 0 times, now this is negative infinity. Here we do care. The side that you approach it on does matter for this one. We get negative infinity. But cosine of 0 is just positive 1. We get 1 times negative infinity, which is itself negative infinity. So there's that. So indeed, x equals 0, which is the y-axis. I'm kind of being boring. I'm just using x equals 0. We could have, guys, there's a lot of different vertical asymptotes. There's examples where x equals 5 will work. But anyway, so for this one, x equals 0 is the vertical asymptote of y equals cosine x over x. Or more formally, this line is the vertical asymptote of the graph of this function right here. Okay. Now for the cube root, you know, this limit is this, that limit is that. So the cube root has no horizontal nor vertical asymptote for the same reasons we talked about before. Now let's do something more interesting. The limit as x goes to 7 from the left of 1 over x minus 7 is negative infinity. Enough said. You know, coming in from the right, we'd have got positive infinity, but that's overkill. So we get a vertical asymptote. Okay, now if I stick a plus 2 out here outside of the limit, well, it doesn't matter if it was inside. Even if it is inside the limit, we can take it out by the constancy rules. So this plus 2, let's just say it's not inside the limit. And that, I guess I ought to have been a little cleaner, but I'll fix it up by and by. Sometimes MathLab acts up when I try to fix things up. So there we go. And that plus 2 didn't mean a thing. So this times 7 is, again, a vertical, x equals 7 is a vertical asymptote. And guys, x equals 7 or x equals anything is a vertical line. In this case, it's x equals 7. But we want x equals 7 for real because that's our vertical asymptote. But x equals 7 is a vertical line. You go over on the positive x-axis to, well, positive in this case, on the positive x-axis, let's just say the x-axis in general, it'll be positive for this example. You go over on the x-axis to 7 and draw a vertical line. And if it was -7, you'd go over to on the negative x-axis to -7. But anyway, anyhow. Now that +2 didn't mean a thing. Notice this +2 didn't really, well, it didn't really affect anything. X equals 7 it is. Now on the horizontal asymptote, we'll see in a bit, it's a little more tender. Now let's talk about horizontal asymptote and Euler's constant E, which we do call Euler's constant. This limit, recall, is E. We assume without proof that it exists. Hence, it's around 2.71828. So y equals E is a horizontal asymptote of this graph right here, of the graph of this function right here. E is irrational, to be honest. The decimal never ends. It never repeats. E is a wild, irrational number, but it's a very special one, though. Now let's go over here. If I stuck a -5 in here, notice it would just come out of the limit. I'd get E -5. That did affect the horizontal asymptote. Y equals E -5 is my horizontal asymptote for the graph of this function here. Guys, there's something I need to point out. E is a constant. E is not a variable. So y equals E is a horizontal line. You go up the y-axis to E, which is ruggedly about 2.71828, and you draw a horizontal line. And whereas for this one with the -5, you go to E -5, which is a constant, in and of itself. You go to E -5, which would give you some negative number, and you would draw a horizontal line there instead for this guy right here. Okay. Now I do some examples of variable substitution. Now here, 4 over 3x, I put that instead of 1 over x, and instead of just plain x, I put 3x over 4. But the trick is to replace it with u. If u is this exponent, 1 over u is this guy right here. So that's the limit. U goes to the infinities, 1 plus 1 over u to the u. But we know by definition that's e. So this limit right here is e after all, where we take a footnote that my variable u is the 3x over 4 right here. Okay, so e is my horizontal asymptote of this guy. Okay, but now what if I try to cause trouble? What if I mess with this one, but not with the exponent? Well, we need to have 3x over 4 up here in a way, but we can't just make it that way because we want it that way. We got to counterbalance. So I multiply that x here by 3/4, and by the law of exponents, I got to raise all this entire 1 plus, this entire jalopy here, the whole thing, I raise it to the 4/3 power. Remember, guys, by the law of exponents, if we did 4/3 times 3x over 4, we'd get x, and that would take me back here where I came from. Ultimately, we're not going to do that because we don't want to go back to the left. We want to proceed. You're like, well, Jason, why are you doing this? I'm going to go what I'm going to do is I'm going to push that 4/3 further away. You remember the limit of something to a power is the overall limit to that power. So we can raise the whole limit to the 4/3 power. That's from the limit rules. And so the limit of jalopy to the limit of jalopy to the 4/3 power is the 4/3 power of the limit of the jalopy. Okay, jalopy being this whole thing right here. Okay, but hey, that's nice. Why did I do that? That 4/3 has been moved out to the side, and now I can replace 3x over 4 with u again. And so I just have u's inside here. But hey, that limit we know from before is e, so that's just e. Now that 4/3 is out here, it's not going away, so we have e to that 4/3 power. But remember, guys, e to the 4/3 power, that 4/3 is 1 plus 1/3, so it's e to the 1. You can think of that as e to the power of 1 plus 1/3, but by the law of exponents, you can break that up as e to the understood 1 times e to the 1/3, which is just e times the cube root of e. And again, well, from a long time ago, we let u equal 3x over 4, but anyway. So there's that. So again, 4/3, you can, in your mind, you can erase this 4/3 and put 1 plus 1/3. And then break that up as e to the 1 times e to the 3rd. Okay. So e to the 4/3 is the horizontal asymptote, HA, of the graph of this function right here. We caused a little bit of trouble, but we still were okay. We had to do some more work, though. So Now once we go through that, we're in, that kind of was the tough part. Now what if I make x, let's just say that I make x go to 0 from either side, and I put 1 over x here. Well, let's see. If x is going to 0 from either side, now here's the thing. Technically, if I let y equal 1 over x, it's a little bit troublesome because y could go to either infinity. So it better not matter which infinity y goes toward. Or if it matters, that means the limit doesn't exist. But ultimately, it doesn't matter. Because remember, from the definition, the limit is y goes to either infinity. I replace x with 1 over y, so I'm going to replace 1 over x with y. So they're mutual reciprocals. So, hey, this is e. It didn't matter. That's really nice. Okay. And if I replace, now this time I'm going to do something different. I'm going to do x squareds. And I'm going to let y equal x squared. Now, if x is going to 0, no, excuse me. If x is going to either infinity, x squared is distinctly going to positive infinity here, okay? But it doesn't matter. I get e. That limit right here is e. I replace x squared with y. So that's good. And now here's the interesting one. What if I put a minus sign here instead of a plus? I go back to my old drawing board, except that instead of that plus sign we'd like to have had, we got a minus sign here. Well, I let u be negative x. So that negative 1 over x is positive 1 over u, and u is just negative x, so x is negative u. They're negatives of each other. Okay, now that's trouble though. I need to take out, notice that's understood to be negative 1 times u, so I take out that negative 1 here by the law of exponents. And remember, the limit of jalopy to the negative 1 is the negative 1 power of the limit of jalopy. And so, that jalopy, and notice something else, guys. Here I had plus or minus. Here I've got minus pluses because it's a negativity change. Whenever x is a positive number, u is a negative number, and vice versa. So I had to, this minus plus means I did a negativity change, but it doesn't matter. It doesn't matter which infinity I go to. By the time I get here, this limit inside here where my cursor is still going to be e. So I get e. Now this negative 1 is still here. It's e to the negative 1 power. But by its very definition, that's 1 over e. And of course, remember, a long, long time ago, we understood that u equaled negative x. So the line y equals 1 over e is a horizontal asymptote of the function y equals this guy right here. Okay, so there's that. And again, if I replace, let's say I go back to the drawing board, except instead of my pretty x's, I've got 2 x's. Doesn't matter, let u equal 2x. And, if x goes to either infinity, u is going to go to that same infinity, and I just get e. Okay? And so, again, y equals e is the horizontal asymptote. And going down here, I'm kind of going to, I need to watch my time. I'm stuttering here. Sorry. Now, what if I cause trouble and just put x here? Again, now I still let u equal 2x. I just got more work to do. So I still do 1 plus 1 over u. But now, since u is 2x, u halves is just x. So you got to do u halves here. But you got to yank that 1/2 out because I just ultimately want u here. And then then do this thing right here. Bring the square root of the limit, or the limit of the square root of whatever is the square root of the limit of whatever. So that's e to the 1/2 power, and that's the square root of e. And my time is short. So y equals the square root of e. That's a constant horizontal line. That's my horizontal asymptote for this guy. And then going down here, I put a negative in front. And now I'm going to wind up, I got to watch my time. I let u equal negative 2x. So I get negative u halves instead of just u halves. I got to take out negative half. I wind up with e to the negative half. That's 1 over the square root of e, which is, when you multiply top and bottom by radical e, you get square root of e over e. So we get radical e over e is the horizontal asymptote of this graph. And some professors will make you do this last step. Some might not. Just depends on your professor there, okay? I'm out of time, guys. See you on the next video. And we'll do some more of these breather exercises.